Hello, I'm Professor Seth Frine. Welcome back to the NLP for Gov Toolkit, where we're going to focus on what you do on computational tools we've developed for processing institutional statements that have been parsed according to our partial implementation of the institutional grammar framework. So you've run the pre-processing notebook for the institutional for your institutional statements, and then you have performed an institutional grammar parsing for attributes, objects, deontics, and aims. Out of that, you got a main.csv file, and now we're going to input that file to the next notebook, abdico clustering, for the step 3 in this pipeline, and this is going to show one thing that you can do. In a way, it cleans up the data. There's a lot of attributes in a policy, and a lot of those attributes in a policy are the same thing. In data I've worked with, we have an entity that in text can be written as the committee, project management committee, or PMC, which is the acronym for project management committee. Those are all the same thing, but they'll show up as strings of text that are literally different from each other. So there's a question of how do we identify that they're the same? Well, there's one method in one computational method is called topic analysis, and we use refinements of it to take the output of the parsing notebook and cluster them into a smaller number of topics that successfully combine the committee, PMC, project management committee, that successfully combine semantically similar roles, whether in attribute or object or deontic or aim, into a smaller number of entities that we can say, well, all these things are really the same kind of role, and that allows us to cluster institutional statements more densely, to say that this institutional statement about management committees and that institutional statement about PMCs, they're linked because they're actually about the same thing. So let's open this notebook. I'm going to go back to Colab. We'll upload. Here we are. Clustering. This is all, I've showed you how to download the zip of the NLP for Gov toolbox, and that was the file directory structure I just uploaded this notebook from. Here we are in Google Colab with the abdico clustering notebook. I'm going to start it running. I think this is a relatively faster upload, but I'll walk us through the code while that is going. We'll be uploading the output of a prior analysis of a parse we just ran. Or I'll use this. I'm going to start off with the sample data provided by the notebook. I like to download it and then upload it again tediously, but you can also, instead of, if you just want to kind of run through the code without fiddling, just to literally see what it does, instead of running this block here, you can delete, you can literally just delete the hashtag there and run this block, and this will automatically kind of grab the data for you, so you don't have to download it like I just did and then upload it. That's our setup installation is still running. I'll let that keep going and just walk further down. Once that's done, you run this block, and this block is the kind of main block performing the analysis, performing the clustering analysis. You're going to give it a component. You get to choose, you have to write aim, object, attribute, or deontic. This is a parameter, like a clustering level parameter. We give it to you to change. You'll change this maybe usually between 3 and 10 is kind of a usual range. I often do 5. I think for this data set we found that 3 was kind of the best. And what does the best mean? Topic modeling is a little bit of a gut thing. So if you get the subjective sense that your topics are good, that they're about the same thing, then you run with it and you sort of say what you'll report for why you picked top N words. Same thing with number of topics. Why you picked 20 instead of 5 or 15 or 10 or 200 often. What you'll say is, we subjectively set these parameters on the we set these parameters on the basis of subjective fit or expert evaluation is how I say it. Okay, we're still waiting for that to load. So anyway, you'll run this analysis several times. For each component, you'll kind of play with top N words, which is the number of words, the number of essentially dominant words that are being used to represent every group. This is a little bit this will help you give all these topics names, because in topic analysis you name your topics afterwards. So it'll kind of take reading that the algorithm clustered these 6 nouns together, and you'll see, oh, well, this says committee, and this says project management committee, and this says PMC. Oh, this cluster must be the PMC cluster. That's topic analysis is very much this kind of like subjective process, but it does work. When it works, it works. And if you don't get that subjective sense that it worked, it's actually just kind of best to move on and find another approach. You don't want to run with topics that you don't believe. This is a bigger subject. I'm very superficially glossing over topic modeling, but I'll show you how to review the results. We can do that now. And I'm gonna pull in some data. Let's sample this data. All right, here we have documents. It's gonna make sure that whatever you upload has a column that you've given a header document, and that's what's going to be. Actually, is that even correct? Okay, here we are. Sorry, let's take another look at the requirements. The requirements here are you're going to need, you want to upload something that has columns for each of these, attribute, object, deontic, or aim, and it's going to base off of that. What we have, ASF Abdico. So what I just downloaded was, I just downloaded this. I'm going to move it into our work folder. Here we are. Then we're going to peek at it. Okay, and so this is the output of the prior step of analysis. And here they are. These are so what we've actually done here is we had to take the attribute inf, object inf, aim inf, deontic inf that were the output of the previous step, the Abdico sub parsing step, and we had to remove the INF and capitalize these to make them say attribute, object, aim, and deontic. Or you can put in your own hand-coded labels as the input to this step. Just make sure the columns are the right name, and it's going to, I think it's also going to use the document column. I don't know if that's documented here, because it's going to use it a little bit for context to help us understand, or it's using the neighboring context around these words to say that they're related, I'm pretty sure. Is how we implemented this for you all. So, now that we have, let me do the upload now. There we are. It's a little strange. There it is. This is the one we just downloaded from here. All right, now the data is uploaded, and now we can run. I'm running with these default values. We're going to cluster over the aims. So these are all the verbs. And let's just decide. Let's use our gut and see how it feels. So it's performing the analysis, and then this is going to download the analysis, and we'll take a look at the clusters that we got out of it, the 20 clusters that it decided were appropriate for this data set. of how many institutional statements? 250. So we're getting, in this case, about 20 topics out of 260 institutional statements. We have much more extensive documentation on all of this. There are a lot more parameters that as your proficiency improves and your comfort and your interest in experimenting improves, there's a lot more you can do kind of under the hood to refine your outputs and so on. But we leave you with kind of the main high-level parameters that'll get you most of the way there. Okay, so we have downloaded our analysis. Now we're going to take a look. I'm going to move this over again. Let's see how it looks. What verbs is the analysis deciding are synonymous? Essentially, what governed actions, what regulated actions are roughly equivalent? I'm going to sort by, so we input a document that had a lot of columns. What's being output is a column that has the aim extracted one-to-one from the input, and then aim group, which is the clusters. This is a number of the cluster, which isn't super meaningful, along with the main words that it brought together: include, including, included, contain. And I'm going to sort by B here in Excel. Sort by B. Okay. All right. So these are all the verbs akin to ask, requires, required, or has. Those aren't super well connected, but I've seen worse. A lot of requires and ask. They kind of got bundled together. When you see two different things very cleanly get bundled together, that's sometimes a sign that you want more. You want to increase the number of topics. Be and expect is R. Very nice. These are almost like things to clean up. Oh, are they ranked by? Oh, and it didn't end up using 20 groups. It only ended up using 8. So it decided to use fewer than we offered. These are all being clustered together. Add, sent, issue, post, perform, invite, offers, hold, mitigate. These are these are mostly things you do to documents. What do we have here? Send, transfer, contact. So these are regulating acts of communication or information transfer. Note, try, find, watch. These seem to be about not exactly monitoring. Report, measure, explain, wait, consider, consult. I'm having trouble finding a clean relationship between those things. Include and contain. So this may be about correspondence. You'd want to look at the institutional statements that include is being used in to see what they have in common. Oh, and then make, create, produce. Okay, so this is very much about institutional statements likely related to production. So you can see, this is just out of the box parameters, and this is what we're able to get. Let me do it again with some data that we haven't played with, and we'll see how satisfied we are with its outputs. Just something that I haven't touched. What do I have? I'm literally just going to. Okay, this is data set. This is fishery stuff, so we'll see if that works. But I think I've done that before, so I want to be a little bit more experimental. Topic output. More ASF is what data set you're seeing a lot of from us, because this is what we developed on. It's our main here. Nope. Here's some hand-coded aquaculture, deontic aim object. We can try it. Great. Yeah, we'll try that. Okay. Fishery. And again, so this is freshly output from the parsing notebook. We're gonna upload it, and I want to cluster the attributes. Attribute. I'm going to rerun it. This is the cell that will enter to pick a file, and I chose the main parsing output fishery document. And now we'll perform the clustering again. It's quite fast. So now we'll download it, and we'll see what we got. Okay, here we are. Let's see, so this is looking fairly nice. I'll make this larger. Oh, it's only finding one cluster, so that's a little bit of a failure. Yeah, I just kind of put everything together. The director, the fish health board, the board, the fish health board, the board. You know, you could say, oh, it succeeded. It's clustering them together, the board members and employees, members of the board, and the fish health board, and the board. But there's only one cluster. It's clustering everything together. Each member. So we would hope to see more clusters than that from this. I don't know. So let's see. Does this... Let me try a smaller number, actually, of top words. And let me see, obviously, a smaller number of topics. Let's just try to set it at 2 topics. Let's see if we can separate members from board. Institutional statements regulating the board's activities, institutional statements regulating member activities. And you can see this is an iterative process. I'm using my intuition and domain knowledge as well. Okay, throw this into Excel and see what we see. And it's looking like we got the same answer. It's a relatively short document, actually, so maybe it just doesn't have the kind of, let's see, how many lines is it? Yeah, it's about 50 lines, so that makes sense. Is this the same document? Yeah, it's the same. I think we chose it because it's short. I'm gonna find something else hand-coded, kind of from our main. All right. No peeking. In our source, I believe we have data sets. Yeah, there we are. I'll find a longer one from the food policy. I don't play with National Organic Program very much. Is it long enough? Yeah, it's quite long. Okay, good. So we're going to play with this one next, and we'll see if we get better results from a larger data set. Once again, we upload. I'm going to drag. I don't know if you know this about Mac. You can drag into upload screens, and now we're going to run our topic analysis again. I'm going to pump number of topics back up to 20 and number of top N words. I don't know. I think I always find 3 kind of low. Top N words doesn't actually change the result. It just changes the labels of the result. So I was mistaken to focus on that. Here we are. So we'll try one more time. Here we are. Replace. And let's open this and see what we see. See how many topics we get. Again, I'm going to sort by column B. Okay. So let's see, what do we get? And I want to make this column a little larger. Oh yeah, it's pretty, look at that. So we're getting a cluster for the producer and producers. And then we're getting, yeah, and that's being clustered in with the certifying agent or agency. So you might increase that number of clusters. You can also combine clusters. So here we're getting a lot of the producer, even though it's a different cluster. So you might combine those. It's not out of the question to be doing kind of cleanup work, or you do a manual pass, especially if you can get multiple people to agree independently. We're getting a third producer. This is producer, handler, processor, certifier, and it's basically the same string over and over. This is almost an artifact of the hand coding process, really. Now we're starting to get some variety after 3 clusters that are all the producer one way or another. We're getting an operation. Then we're getting the USDA, very nice. Yeah, look at that. The United States Department of Agriculture, the U.S. Department of Agriculture, USDA are all identified as being the same thing. This is the magic of context-informed topic analysis, which is what we implement for you. This is automatic. It's not this. You would imagine this is a hand process, but we're able to do it. We're able to automate it for you. The USDA, United States Department of Agriculture, and U.S. Department of Agriculture, same cluster. So you can see it would be a kind of a pain to automatically go through and identify that these are all about the same thing. We are able to do that for you automatically here. The program manager, that's a little redundant. The peer review panel members and the secretary kind of got bundled together. This is such a large policy that it produces. I almost wonder, actually, with such a large policy, if we should have done a larger number of clusters. And here we are. Okay, yeah, we got 20 clusters out of it, it looks like. You see that? Anyway, this is nice. The state organic program's governing state official or certifying agent gets clustered with the administrator or state organic program's governing state official. Yeah? Yeah. The certifying agent, a state organic program. Oh, that's interesting. So that might almost go back up with the first one. Yeah, I would do a larger number. Oh, no. Maybe it was appropriate. I mistook program and producer. But that kind of works. Anyhow, you can tell, once again, it's an iterative process. You try it a couple times. I don't have the domain knowledge to know what NOSB is, but National Organic Certification something board, standards board. But yeah, I would use that to inform this. And overall, I'm seeing some pretty clean clusters. Oh, there it is. Nope. Some pretty clean clusters, but I think I would pump up top number of topics maybe to 40 for this one and try again and keep filtering until I find something that feels satisfactory. Anyhow, overall, I think we can be pleased with this performance and this iterative process for a document that big, or for a set of policies that big. For a policy that big, for a set of institutional statements that big, you're going to be you're going to spend less time on this iterative process, on this, which is ultimately more reproducible and more scalable than you are kind of hand fiddling with this clustering process by yourself on every single time that you have to kind of update this analysis or do more data. So hopefully this saves you time and gives you a first pass to perform interpretable, high-level analyses of parsed institutional statements with a tractable number of agents, objects, aims, and deontics represented. So there's a lot more to say about all this, but hopefully this gets you started. Ultimately, we want you to be able to hit play, upload a data set, hit play again, and get useful data out, even if you're not yourself trained or familiar with code. So thank you very much. I hope it's useful to you.